Hey, this is Alex from Gretel. Today we're going to walk through using Gretel's APIs to create a synthetic version of a healthcare EHR, so electronic health record dataset. Go ahead and click Dashboard. We'll choose File. And from here, we'll go ahead and upload an example EHR dataset. I'm going to take a look at a preview here in just a minute. We'll create a new project. We'll call it Hospital EHR Data. From here, we can choose which of the Gretel APIs we'd like to run. Today, we'll choose Generate Synthetic Data. We get a preview of the data set here in just a minute, so we can see there's 18 fields, about 10,000 records we're going to be training our model on. You have a variety of configurations we can run. Here we see from running differential privacy to tailoring the hyperparameters to work well with numeric data. You have a fair amount of choices. We're going to go with the default setting today, and we can see these hyperparameters. These parameters are meant to work well across a variety of different data sets and really help you balance both accuracy and privacy in your data. From here, we'll click Begin Training and take a look at this data. So here we can see about preview of the first 20 records, and across the different fields, we see both categorical data such as hospital codes and things like that. We see departments. We see age ranges and things like that. And this really highlights some of the flexibility we have with the synthetic model. We don't have to tell it this is an age range or a bucket that it needs to learn, or that these stay ranges are in a series of dates. Underlying the model here is a synthetic language model, which essentially just treats this as a new language that it needs to learn and recreate. We also set the parameters here to apply privacy filtering. So when the model generates a new data set of the same size and shape as this, we'll apply filters to that model to make sure that the output is not too close or too different from the original data set. The goal being create a new data set with artificial records that don't point back to any of the real world data, that's resistant to the known attacks on privacy, such as membership inference attacks, joinability, and linkage attacks. So plenty of more information about that on our blog. Here we can see the worker starting up. With Gretel, you have the option of running workers either in our cloud, where you have basically infinite scale out ability, or running within your own cloud if you have security reasons you need to run inside of a VPC, for example. Gretel APIs can be deployed as containers inside your environment, connected up to a data pipeline to run automatically. The interfaces that we see most often with developers are either Python notebooks using our Python SDK command line, or the ability to train with absolutely no code, as you've seen here, using the console workflows. It's loaded the data up and it's beginning model training. We can see here that training is complete. It went 49 epochs before early stopping kicked in and terminated training due to no longer increasing or decreasing the amount of loss associated with the model. Here we can see accuracy is quite good at 0.82. Loss is also very good at 0.66. We're going to go ahead and sample 5,000 records from the model. This is used to evaluate the accuracy and the privacy of the synthetic data and synthetic model versus the real world data that it was trained on. Next, we'll go ahead and take a look at the quality score. You can see quite good here. So the model is actually very happy with its own ability to learn the insights and distributions in the original source data. You can also see that the privacy protection level is listed as very good. We can dive a level deeper here by taking a look at the raw synthetic report. We'll go ahead and load that up. And go ahead and launch that report. So here you see the same screen we saw before. We can see no training lines were duplicated in our synthetic data set, which is always good to see and will always be blocked by the similarity filters. We can see of our privacy protection filters which ones were turned on. We had outlier detection, similarity, and overfitting all turned on. We did not have differential privacy turned on. If you want to try taking your privacy to the next level, differential privacy is a way to get really strong protection against really both known and unknown attacks on data. It does come at a cost to accuracy. So when you turn on differential privacy, depending on the setting you're working on and the size of your data set, you will see a hit in accuracy, but with that comes a much stronger guarantee around privacy. Here you see each different field and an overview of the distribution of elements inside that field. We're going to really my favorite view here. So I like these next two views personally for evaluating the quality or the fitness of our synthetic model. What we're looking for here is we're looking for the correlations that exist in the training set to have been learned by the model and then recreated in the synthetic model as well. So seeing two very similar images here, this looks like a Zelda sword of some sort, is actually very encouraging, and it shows that, for example, some of these strong correlations where you had a facility code and a hospital code, for example, were learned by the model and recreated. It's one of the things this type of synthetic model does a very good job at learning, is correlations that may be 2 or even multiple, let's say 5, 6, 7 levels deep in data. Another way to look at the same data here is taking a PCA view. So principal component analysis, favorite tool in a data scientist toolkit here to essentially reduce the dimensionality of the data set here. What we're looking for is a similar distribution of elements across the real world data and the synthetic data, which we see here indicates that the model didn't overfit. And finally, we can look at the distribution for each field and say, does the distribution, for example, for the length of stay in numbers of days, for example, or the hospital code, or the amount of money in the admission deposit approximately line up between the real world data and the synthetic data. Once again, very encouraging. You're looking for similar distributions across elements here as an indication the model learned and recreated the data without recreating it exactly. From here, you have a synthetic model that you can use to generate as much data as you want to. So you can go back to the model and you can use it to generate more data, or you can go ahead and train a new model on new data.